Hey guys, today we're talking about 3.5 tangent and cotangent graphs. Okay, they're a little bit different than sine and cosine, but I'm going to just show you how to graph them. And if you're curious where these numbers come from, you might want to pull out your calculator so you can kind of see where I'm getting these numbers from. Okay, so the parent function of y equals tangent of x. One period is 90 degrees, okay, as opposed to sine and cosine, which is 360 degrees. So you might want to make a mark and write that down. Period is 180 degrees, okay? Something else that we have with tangent and cotangent, they're called asymptotes. I know you've talked about them before in Algebra 2. But for tangent, there are asymptotes at negative 90 and positive 90. Okay? As a reminder, tangent is equivalent to your y value over your x value, or you'll also hear it as sine over cosine. Okay? If we're thinking of our unit circle, okay, 90 degrees is right there, and negative 90 degrees is down there, which is also known as 270 degrees. But our point values are 0, positive 1 for 90 degrees, and 0, negative 1 for negative 90 degrees. Okay? If we were to put y over x for tangent of 90, we would have 1 over 0, which is undefined, hence it makes an asymptote. Same is true for tangent of negative 90, 1 over 0, hence another asymptote. Okay? The next thing, with tangent at 0 degrees, our point value is at 1, 0. Okay, again, we're going to put our y over our x, so in this case we'd have 0 over 1. So tangent goes through, I'm going to use red, tangent goes through the origin. Okay? The other critical points that y'all need to know is at 45 and negative 45. Okay, back to the unit circle. I'm running out of space here, but I've got square root of 2 over 2, square root of 2 over 2. Again, if I put square root of 2 over 2 over the square root of 2 over 2, I would get 1, which would be right there. And the same is true for negative 45 degrees. My y value would be negative, x value would be positive, but they'd still be the square root of 2 over 2 each time. So that's my second point. Now, I want to use red. It doesn't create a straight line. It creates like a swirly, that's a terrible one, but a line that is small and then it rises up closer and closer and closer until it gets close to touching the asymptote, but it never completely touches. Okay? So this is the parent function of y equals tangent of x. Okay, next one is cotangent. So y equals cotangent of x. As a reminder, cotangent is equal to your cosine over your sine, which is also the same as x over y in terms of our unit circle. Okay? Our period, again, for this is 180 degrees for cotangent. Okay? But the difference is there's going to be asymptotes at 0 and 180. Because if we go back to the tangent, remember when I made these points at 90 degrees, our coordinate is 0, 1. So cotangent is x over y. So 0 over 1 would still create a 0. So this is 90 degrees. This would be like my center point. Okay. And at the 0, at 0 degrees, it's 1, 0. And our x is 1, y is 0. So again, that would create an asymptote. At 0 degrees and 180 degrees. Okay? Again, another critical point is positive 45 and then 135. And you know it repeats going to the left. I'm just showing you one period between 0 and 180. Okay? So if we're looking at 45 degrees, okay, cotangent is my x value over my y value, which would still give me 1. So right there. And then at 135, okay, 135, remember it's in the second quadrant. My x value is negative, so hence that would give me negative 1. So, oh, I need to erase that real quick. So roughly, roughly looks like that. If you Google it or if you do it on your calculator, you'll see it's a little bit nicer. Okay? So one more thing I want to talk about is the asymptotes of these graphs. So asymptotes for the parent function. Asymptotes for y equals tangent of x and y equals cotangent of x. Okay, so there are asymptotes, and here's a hint, sine of x, cosine of x. So let's think about what creates an asymptote. Okay, when there is a 0 on bottom of the fraction. Okay, so with tangent, it is where cosine of x equals 0, which would be where x equals 90 plus 180 n. So it could go on forever, depending on where n is. Again, same with cotangent, except cosine is on top, sine's on the bottom. So it's where sine of x equals 0, which is at when x equals 180 times n. Okay, I'm going to give you one sample problem, and that is it. Oh, that's our phone. Okay. Let's do y equals tangent of 3x. All right. So as a reminder, the standard equation, the y equals c plus a sine of b of theta minus d, is still the same for tangent and cotangent. The only difference is we have b equals 3, but with sine and cosine, we divided our b by 360. However, our period length for our parent function is 180, so that's what we're going to divide our parent function by. So we get 360, or 180 divided by 3, which is 60 degrees. Okay. So which means we're going to squish together our graph. Okay. Also, you want to divide by 2 because we've got 0 degrees is at 0, 0. We got positive 30 degrees here, negative 30 degrees there, and then you're going to half it again. So like this is how we're finding our critical points. So 15 and negative 15. All right, so our asymptotes are at positive 30, negative 30. Negative 15 is in negative 1, positive 15, positive 1. So our graph looks like that. And that is how you graph tangent. Okay?